So in this section, I'm going to talk about computer security. Now, computer security is kind of a scary, sort of dramatic topic, but it doesn't need to be. So I'm going to talk about some of the most important cases, and in particular, staying safe is not that hard. It doesn't need to be that complicated. So for starters, I want to establish this model of the computer. I'll say the computer is sort of like a castle. So let's say here I've drawn the computer, and there's the CPU, and maybe here's a hard drive or a flash drive or something with bytes on it that you care about. And let's say you've got your secret diary.txt. There's some bytes here that you care about. So I'm going to say it's like a castle in that the computer has this sort of, I've drawn this bold border around the side. Like it has a real a wall, and the bad guy's out here. He's outside the wall. Now in the movies, sometimes it seems like, well, the bad guy just drives up in a van, outside your house, and they have some gadget, and then, they just do something and they just get the bytes off there. And that's just not how it works. By default, the bytes are on the computer. You've got the computer. The bad guy's out here on the outside. Like, by default, it's kind of safe. Or put another way, when we look at the different things the bad guy might do, they all involve being on the outside and trying to get inside. But by default, they're outside. So what I want to do is talk about the different so-called attacks that the bad guy might do. One sort of broad pattern I want to emphasize is that it's not the case that there's a bad guy with a picture of you sitting in some apartment, like scheming how to get onto like your computer. Generally, the way it works is that the bad guys are working what you would say in bulk. They don't know about you. They don't know about anyone in particular. They're just crafting not fairly medium complicated attacks and then just sending out millions and millions of copies of that attack. Not putting any thought into any particular one, just trying to snag essentially victims who have taken the least precautions. So if you just do, it's not that you need to have super awesome security, you just need to avoid making very common mistakes. And if you just avoid the common mistakes, you're probably going to be okay. I should mention that sometimes for like corporate espionage or whatever, you might get a government or someone who's trying very hard to break into someone's computer. That's sort of a different class of thing. I'm not going to worry about that case. Presumably, if you work for the CIA or something, you've got your own class. So the first class of attack I'll talk about is password attacks. So the bad guy could try to just guess passwords to get into someone's account. So Gmail or whatever. I'm sure this just happens all the time. This is sometimes called a dictionary attack. The idea being the bad guy could just sort of aardvark, acre, just sort of like go through every word in the dictionary and just guess it. There's 86,400 seconds in a day that kind of give, if they were to guess a password every few seconds, whatever, you could go through quite a few. The trick here to avoid password problems is you just need to avoid very obvious or very common passwords. So your password should never just be a word that appears in a dictionary or a pun or a little bit of wordplay that someone else on the, many other people on the internet might have thought of. So actually, I can show you an example of this is sometimes called a dictionary attack. Maybe I said that. So actually, this is a real example of a dictionary attack. So I run the codingbat.com server, and it just turns out bad guys are trying to break into that thing like all the time. So it keeps a log file of just what's happened. That's a standard thing for servers to do. And I've just put a copy of the log file. So it's a little cryptic, but I'll walk you through it. So what this says is on March 6th at 6:26:20, it says failed password, invalid user Alex from some IP address. That's actually an IP address in Japan. So what's that saying is there was a login attempt and it failed for the user Alex. And then 2 seconds later, there's another one. And then, 4 seconds after that, there's another one. So the Alex 3 times, and then there's a failed one for Adam and for user fax and whatever. And so this kind of shows you the sort of bulk quality. So there's just some bad guy machine out there, and you can see every 2 or 3 seconds, it's just trying another password. And it's just always wrong, right? It's just guessing a word in the dictionary. I mean, what are the odds that that's going to happen to match? It's very, very low. But that's how the bad guys operate. It's not that they have a high percentage idea. It's quite the opposite. They have this very low percentage idea, and then they just try it a very large number of times. So it's also, I think, funny that you can see they have sort of a list of usernames to try, and it's kind of alphabetical, right? Like it's just totally bulk. They're just going through them So that's just kind of, so that, I guess, not to be too scary here, but that's just going on all the time, right? The bad guys are just trying every server they can find every couple seconds, whatever, just like constantly. So I'll talk about in a second. If you just have a password that's just a little bit hard to guess, you're totally fine. They're only guessing the most obvious kind of passwords for that sort of attack. So here's I thought it was interesting. I just looked up a list of just common passwords. So here's, I'm sure it depends on how the survey is done, but here's some common passwords. So the number one common password was the word password. Number two was password one. No doubt that's when they require you put a number on there. And some of you out there may have actually done that. Or here someone has password 1 through 9 or 1 through 8. Or here ABC 1 2 3. It's not a word, but it's kind of a pattern. It's pretty easy to imagine a lot of people trying that password. Or QWERTY. Another example, someone's trying to be clever, but if you're clever in a way that like a million other people are going to have that same idea, then it's not clever. So those are all password patterns to avoid, right? You can't pick something so obvious that other people might try it. So the good news is that having a secure password, it's not really that hard. And some sites, in my opinion, really go overboard, requiring you have a bunch of digits and multiple punctuation. I think they're fooling themselves. I think that is excessive. So I'll just give you some examples of what, in my opinion, represents good passwords. And I should say, I use good passwords for, the bad guys are really interested in sites that involve money. So banks, eBay, PayPal, or your email account. Your email account is important because the bad guys can then trigger a password reset, which is then sent to your email account, and then there might be some other barriers there, but that's maybe a way for them to get at the account with money. So those are passwords I regard as important. And then there might be some other, blog where you want to comment or whatever, and I don't put a lot of thought into using a real secure password for that. So I'm conscious of passwords where I care about security versus kind of, whatever, throwaway passwords. So here's what I do. Start with a word. Here I use the example mittens, just some random word, and I add a little misspelling. Change the letter, mess it up a little bit, so it's not quite right. And then here I added comma ERX, just a little random something in the middle or the beginning and the end or something, so it's really not a word anymore. That's pretty good. It's important here that the ERX, it's not like ABC or XYZ or something that anyone else on earth would have thought of. It's just really random jumble, a few letters. So this kind of password I find to be pretty easy to type. If you want to get a little more fancy, you could start adding some uppercase letters, or maybe put a digit in there. A lot of sites require digits. Or if we want to really go over the top, we could have like multiple uppercase letters and lowercase and multiple digits and punctuation, whatever. That's probably more complicated than is necessary. So those are pretty good passwords. There's another problem, which is instead of the bad guy guessing the password, it might be that the bad guy, let's say they break, I'm going to use schwab.com as my example a lot of times. So what if they break into schwab.com and they sort of get all the passwords from inside of there? And there's some technical details about how that might work. It's important, for that reason, it is important that you do not reuse important passwords. If you did reuse it, then there's this other problem, even if it is hard to guess, where it could kind of get stolen, not from you, but essentially from someone else. So I don't reuse important passwords. This does create a problem where they're really hard to remember. And I gotta say, what I do is I just write them down. Like you could have a piece of paper somewhere obscure in your house, and for the important ones, just write them down. And I find that to be adequate. You have to realize, again, it's not that there's some bunch of, the CIA or something is trying to like break into your account and hiring people to break into your house and get the passwords. It's more, there's just this mindless bulk and in a way very inexpensive operation going on, just trying to take advantage of common cases. So I'm not so worried about having those written down. Also, if you were in the hospital or something, it might be helpful for other people that they could get your passwords. Alrighty. So that's the first class of attack, password problems. So the second class of attack I'll talk about here is called phishing, and it's spelled with a PH, phishing. And the idea here with phishing is that you are the fish. So the bad guy is putting out this bait and trying to trick you into revealing, most commonly, your password or something that the bad guy wants. So no doubt you've received many emails that claim to be from eBay or PayPal, right? Again, anything to do with money, where really those are phishing attempts, where it's trying to trick you into giving up your password. The email might say something provocative to try and get you to click. It might say, fraud emergency, click now, or whatever, something to try and get you to react in the moment. So I'll scroll down here and show you. This is an example of a phishing email I got. And I guess the thing about phishing emails is they look realistic. So this is a forgery of an email that claims to be from eBay, so they can get the art, the logo and the text and all that kind of stuff. It's very easy for them to copy it, so it looks, it's not always done perfectly, but it might look really correct. And the trick here is really the links. So if you look at, there's a link here and a link here, there's all sorts of links in this thing. And if I click any of those, this is just a picture of the email, but if I were to click one of those, the trick is it does not lead to a page that's actually an eBay page. It leads to a fake eBay page, a phishing page that will then prompt me for a username and password. And the idea is that fake phishing page, the bad guy is using that just to get my password from me. So it's a forgery. They put up a forgery of a phishing site that looks like eBay and try and trick me to typing my password into it. So if you want to sort of isolate down to just the case, think about when you're typing in your password, you want to look and be like, wait, who am I typing that to? That's the case you want to think about. I should point out, and this sort of fits with what I was saying about bulk, notice the to member at eBay. Like, they haven't bothered to use my right name or my right email address. I mean, it looks wrong in many ways. It's just the most mindless thing, and they're just bulk sending out millions of copies. Because, of course, it's tough because eBay does, in fact, send email to its users. And so if you're receiving email, it puts you in this tough spot where you're trying to distinguish the good ones from the bad ones. Now in this case, it's an email. There's a very similar idea of just a website that's maybe it's just the phishing website, and then the bad guy might just try and send the URLs to that website and put them in blogs or whatever, and just the same sort of idea, trying to get people to go to the bad site. So I'll talk about how to avoid this problem in a second. There is a funny analogy to this idea of a phishing site, which is a crime. Which I guess it's happened more commonly, but I'd first read about it, where some criminals, they went to a bank. It was a long weekend, and so they got some plywood and some screens and keyboards or whatever, and they put up a fake ATM machine outside of a bank, and they put a sign on it that said, pardon our dust, under construction. And so then what would happen is people would come up to it. They'd think it was a real ATM machine. They'd put their card in. It would say, type in your PIN. They would type in their PIN. And then it would wait a second. It would say, network down. Try again later. Now, really what was happening is the machine was just recording their card details and their PIN number. Right? Exactly like a phishing site, right? It tricked them into putting in their PIN number, and then the criminals went and tried to drain the accounts. And since it was a long weekend, they had a few days to try and get money out before Monday people came back to the bank and realized what was going on. So I did a little Google search preparing for this. Apparently this actually goes on to this day, where people set up little fake ATMs at different places. Just it's the same crime. So it's just interesting that that's sort of the real world analogy to the phishing emails, the phishing sites. All right, so how do you avoid this? So the first thing is, if you receive an email or you're looking at a blog post or something where it's sort of content really could be from anybody, you want to be suspicious of URLs in there. And in particular, if you ever get to a point where it's prompting you for a password, you want to think about, well, wait, what page is that? Is that really eBay? Sometimes the URLs they come up with, it might be www.ebay.badguy.ru. So if you sort of look at the URL from left to right, it looks like eBay. It's only if you really look at the entire thing you can say, hey, wait a minute, that's not eBay. So scrutinizing the URL is one possible thing to do. And actually, I'll give you an example of that. So here in this other tab, so that I just went to the Schwab site because I have an account there. So when I say look at the URL, what I mean is look up here, right? I see the page down here and it's asking me for whatever, but if I want to know, well, wait, who's asking me? Then you could look up here. It's also the case that because financial sites are just attacked so regularly, the browsers and the sites themselves have come up with some extra stuff where it knows Firefox is putting this little green marking here saying, hey, here's really the corporate name of that, and here's the country. So it gives me a little bit more visual cue, like, oh, who am I talking to here? Now it's tough because, like, the bad guys, they just need this to succeed 1% of the time. And of course, anyone could try to pay attention, but it's hard every time to always be paying attention. So if you remember nothing else, I'd say whenever you're asked to type in a password, always pause and be like, wait a minute, who am I typing this to? So another thing you can do, which is even simpler, is if you ever get an email or something that says, oh, you need to log into eBay right now and fix something, you could just go to the browser and just don't click on the link. Just go to the browser and just type in www.ebay.com. And that way you're not subject to the bad guys trying to like sort of trick you to click over to the wrong URL, right? You just typed in eBay, it's going to go to the right one. So that's what I tell my parents to do, actually, because it's a very simple rule to follow if you're unsure. Alrighty. So as I'll scroll down in a second, the other thing I'm going to talk about here is normally at the very left of the URL it says HTTP, but there's a variant HTTPS, the secure one. And so usually if the information is sensitive in some way, it's going to use HTTPS, and then you'll see these green things. I'll talk about that in a second. Alrighty, so actually that's our next topic here. So HTTPS adds some some security features that are attractive for a site like Schwab.com. And actually it does two things. The secure variant, HTTPS, verifies that it really is Schwab.com or whatever on the other end. And there's some technical measures it can make there where Schwab has to file a certificate and do some other paperwork so that that can be verified for HTTPS. So that's good. So that helps with anti-phishing. The other thing that HTTPS does is it encrypts. And so the packets that are going to be sent from my browser over to Schwab.com and back and forth, whatever, both ways, HTTPS provides encryption. So I don't think I've talked about encryption up to now, but what encryption does is it scrambles the data. And so at one end, I'm in my browser, it's going to scramble the data and then put it on the wire. And the result is if a bad guy intercepts the data, it's just going to look like gibberish to them. They can't read it and they can't forge, put stuff into the conversation. And likewise for the packets coming back with my data. So you may remember from the networking section, I talked about how on Ethernet or for Wi-Fi, when my computer broadcasts a packet, it's broadcast, right? Everybody around me can just see it. And so a natural question would be, so if I'm on my browser, if I'm on my computer and I'm going to log into, I'm going to type in my password to Schwab.com, is that password just going to be visible to everybody within 50 feet of me? If they were listening, could they just see it? And so so I did this as an experiment actually. So what I did, here's a picture of it. So I went to Starbucks. And I just logged into their free Wi-Fi. Right, so I've just got my coffee here. I'm sitting, and there's must have been at least 50 other people around there, and like 48 of them had laptops, and I'm sure many of those, probably multiple of those laptops had some kind of malware that had broken into the laptop and was like messing around. And the bad guys famously are very interested in financial sites, so they might have been kind of sniffing around for trying to detect someone logging into Schwab.com or something. So I went to Starbucks, I did this, and I typed in my password, I hit return, and that was fine. That didn't cause any problems. The reason is HTTPS. That if you look at the Schwab page, well, you can't, it's too small here, but when I went to the Schwab page, it was an HTTPS connection, and so that meant that when on my computer here, when I typed in my password and hit return, it was being encrypted, and then the packet was being sent out. So even though all the people around me, if they wanted to, their computers could have been intercepting packets that I was sending, and they could look at them, but because they were encrypted, it would have just looked like gibberish. They couldn't have seen what my password was. So in fact, whatever, I did this, and it's always hard to know that you haven't been hacked, but yeah, my account still has money in it. Whatever, technically, yes, that's a fine thing to do. So anyway, that just sort of demonstrates what does encryption mean? Why? How would that help you? The other thing I should point out is if my laptop had malware on it, like somehow earlier my machine had been compromised and the bad guy had control of my machine, then HTTPS would not have helped. Right? So malware on if it gets on your machine, it could observe what you're typing and keep logs and send information stuff or whatever. You really just need to wipe the machine at that point. But in terms of putting packets out there, HTTPS is a good solution. All right, so that was the second class of attacks. So now I'll talk about this big third category, which I'll just put under the term malware. Malware just meaning basically software that's trying to do something bad to you. So I'm treating this very broadly. I'm lumping viruses and Trojans and worms all into this category, and I'll just talk about them broadly. So the question I want you to think about is, suppose a bad guy, or someone you don't know, sends a file to you, and you're going to download it onto your computer. And I want to think about, or I want to look at how you might feel about that file. So one example is, well, maybe it's just a plain text file, and you double-click it, and it's text, and you look at it. Or maybe it's a JPEG file. It's an image, a bunch of bytes, gets copied on your computer, you double-click it, you look at it. And I'll tell you, these two cases, that's fine. Even if it's a bad guy. The bad guy could just send you a rude picture or bad poetry or whatever, but it's just not going to compromise your machine. It's passive. It's just data. You're just looking at it. So the scary case is if the bad guy sends you a .exe, a program. Now, .exe is just a Windows convention for how to name files. Programs can be named different ways, but I'm just going to use exe for sort of my nomenclature for this lecture. So the way it works is, well, I'll skip to the punchline. So the exe file is very bad. If the bad guy can write a program and send it to you and get you to download it onto your computer and then run it, now my castle model is broken. They've gotten in the walls and they can do almost anything they want. The way to think about this is, well, suppose the bad guy was literally sitting in front of your computer and clicking on the hard drive and looking for stuff, whatever. They could do something bad. So the program is actually very similar, because the bad guy could write the program so that the program looks at your files and delete things or mails or whatever. Whatever it is the bad guy wanted to do, they could just put it in the program, and then they send the program to you. You double-click the program, and now it's just doing whatever the bad guy wanted. So that is the key bad case. A program written by the bad guy, but running on your computer. And so later on, I'll talk about different things the bad guy might do, but they're all sort of getting back to this. The bad guy is trying to get their code, their bad program, onto your computer and get you to run it. Or put another way, this is sort of the key distinction between passive things like the text or the JPEG versus program. Like those are two entitled, or it's the active program content. That's the scary one. So obviously something with the name .exe on Windows, you're like, oh, okay, well that's obviously a program. Unfortunately, so things like the .doc, the Microsoft .doc format, which you think of as kind of passive, but actually there are coding features in there. And so something like a .doc can act like a program. And at one time, this was a huge source of problems if you look for the term macro virus. So what you'll notice now is if you get a .doc and it has some code in it, what most programs will do is if you double-click it, it'll put up a warning. It'll say, hey, this has code in it. Are you sure you want to run it? And so that's getting at this case that has a bad guy crafted a .doc with some bad code in it, trying to take advantage of you. All right, so I want to talk about how it is that the bad guy could get their program on your computer and get you to run it. So one common technique is called a Trojan. And this is referring to the story of the Trojan horse. So the idea is that the bad guy has their program and it's going to do something bad to your computer, but they just disguise it. So a simple example, maybe they call it Justin Bieber JPEG.exe. So it's trying to look like, oh, it's a picture of a celebrity, but really when it's double-clicked, it's a program. And here I use .exe, but really there are many different file extensions or ways that something could be disguised. So it's casually, it looks like an image, but really it's a program. Actually, ironically, a common way to do a Trojan is to claim to be antivirus software. They could advertise it or whatever. Oh, here it's this awesome, free for this week antivirus program, and it might actually look like it's antivirus. It might put up a fake screen where it pretends to be scanning or whatever, but really it's just a Trojan and it's just doing something awful to your computer. So, I guess the key thing here is to just be cognizant of when a program written by someone you're not really sure who it is, you're copying it onto your computer and running it. What you might do is just the name of the where it's from or who claims to write it. You could just Google it and just sort of see. My expectation is that if something is a Trojan and it's out there, within a day, it's going to get figured out that that's what's going on, and there'll be all sorts of articles and blogs about it. And so if I Google it and I see no complaining, I figure, well, that's probably okay. Or obviously if you're downloading it from just a well-known a so-called reputable site, then you might feel okay about it. Alrighty, so that's one Trojan horse. That's one way the executable could get in there. There's another way that is a little more complicated and a little more scary, which is called a vulnerability. So suppose I'm going to use Flash, the Adobe Flash format as my example, because actually in the last year just turns out that's been a big source of problems. So suppose there's a bug in the Flash display program. So Flash is an animation format, and so it's called upon to display Flash animations. And there might be a bug in the Flash animation program such that if the bad guy crafts a very specific sort of animation, the animation will essentially crash or corrupt the display program in such a way that it opens up the computer so the bad guy can get in. So it's a very tragically bad class of bug in the Flash animation, the Flash animation program. So what's scary about this case is all the bad guy needs to do is craft this sort of attack animation that's going to take advantage of this vulnerability, and then just spread it around. Maybe they could email it to a million people, essentially like spam, or they could put it on some website somewhere and then put out a lot of, on Twitter or whatever, a lot of sort of provocative, like, oh, hey, you got to look at this type messages to sort of drive people to try and look at the site. And if they just look at the site and they have the vulnerable software on their computer, then just looking at the page might be enough to get the malware onto their computer. So I regard this as the most scary case because, in a way, as a user, you don't really have to, visiting sites. Well, geez, that's something we all do all the time. So it doesn't take much. So that's the bad news. The good news is that by far the most common way that this is exploited by the bad guys is there's some vulnerability in Flash software. And Adobe figures this out, and within, say, a month, they update a new version that fixes it. And then it might be 6 months or a year later. The most common attacks out there are dealing with vulnerabilities, actually in some cases, that have been fixed for years. So users who have up-to-date software are immune. But to the bad guys, or the way this has worked out as a practical matter, is there's just enough systems out there which are running software which has been out of date for years, and so they still have this vulnerability, and so then the bad guys get onto that system. Again, it has that quality. Well, maybe 80% of the systems are fixed, but to the bad guys, 20%, like, hey, that's plenty. So the cure for this attack is actually pretty simple, which is you want to have your internet-facing software, you really want to have it auto-update. Just have it be on the most current version. All the browser vendors have figured this out, so they tend to default towards just updating automatically. And so it's the things on your computer which are interacting with the internet directly are the ones that are subject to this kind of vulnerability. So that's the case where you want to care about it. Also, just as an aside, this shows how, I don't want to pick on Adobe here, but just turns out we've had a bad experience with them for the last year or so. This shows how having a proprietary format controlled by this one company is not a very good architecture, because it meant that if you were on a Linux machine or a Mac or something where you were dependent on how motivated on top of it was Adobe to push out a fix for your platform. And if Adobe was a little bit, that's awkward to have some other vendor be kind of controlling the performance of your machine in that way. I think I mentioned this before. This is maybe one more reason why HTML5 is gradually going to take over. Okay, so I've just talked about a lot of vulnerabilities, so I think that creates this atmosphere like, nothing's safe, and really, it's not true. I surf the internet all the time like everybody else. I don't have any antivirus software on my machine. I haven't had any problems. It does help that I don't use Microsoft software, and Microsoft is a very big target, so that maybe helps a little bit, but I don't think weird, extraordinary measures are required to use the internet pretty much safely. So I'm just going to recap what I think are the things that are important to get right. Okay, number one, we had the password attack. You just need to not have a lame password. It is not. I don't think you have to have some super awesome, mega complicated password. Just not lame. And don't reuse passwords. All right, we had the phishing attack, where you're going to get an email or something that's going to try and trick you to log in. In this case, you want to look at the URL. Where are you trying to log in? Just be a little bit careful. Or if you want to be very simple, you could just type www.schwab.com or whatever yourself in the browser, and so then you should be getting the right site. Finally, we had the malware attack case, where it's taking advantage of a bug in the software on your computer, and really all you need to do, or the simplest case, is just to make sure that your internet-facing software is set to auto-update. So the bug fixes you get on your computer, and so then like months later, when the bad guys try and use it, like you're already protected. That's all there is to it. All right, so let's stay safe out there.